Hey there, grade six. Hope you're doing well. This is going to be our next lesson on factors and prime numbers and composite numbers, etc. And so today what we're going to do is get a chance to look at NS 6-20, which is a shorter way to find factors. And so the learning target is that you're going to find factors of numbers up to 100 and determine whether a given one-digit number is a factor of a given whole number in the range of 1 to 100, which is a very long way to say we're going to find factors and find ways to do it quickly. There's a couple of skills you need to have beforehand. You need to be able to skip count, probably by 2, 3, 4, and 5. You need to be able to multiply one-digit numbers, mostly in your head, but if you have a calculator, that'll help too. You need to know some division stuff. So two-digit numbers divided by a one-digit number. You need to be able to do long division, and you need to know the relationship between multiplication and division, and then you can divide with remainders as well. Those are all kind of the skills you need. So let's get right into it. First thing that we're going to do is we're going to use some division just to check for some factors. So if we have 15 divided by 3, that's 5. So 3 and 5 are both factors of 15. 16 divided by 3, well, that's going to be 5 remainder 1. 17 divided by 3 is going to be 5 remainder 2. And then 18 divided by 3 is going to be 6. So we have here 3 times, well, we know it's 5. Oh, hang on. 3 times 5 is 15, and then 3 times 6 is 18. Then the question is 3 a factor of any of these numbers? Well, 3 is a factor of 15, and it's a factor of 18, because in 16 and 17 we have remainders. And so if you are doing a question and you get remainders, then the number you're doing the dividing with, in this case it's 3, will not be a factor. So then we're going to just check some other numbers to see whether or not 3 is a factor of these numbers. We can use division to check. So 19 divided by 3 is going to be 6 remainder 1. 20 divided by 3 is going to be 6 remainder 2. And then 21 divided by 3 is 7. So 3 is only a factor of 21 because the other ones have remainders. And then 602. A bit trickier, but it's 200 remainder 2. So no, it does not. Okay, so again, some more practice. We're asking if 4 is a factor of the number. So 18 divided by 4 goes in 4 times with a remainder of 2. 24 divided by 4 is 6. So yes, 4 is a factor of this number. And then 16 divided by 4 is 4. So yes, 4 is a factor of that number as well. Okay, so this is just using some division to quickly find out if a number is a factor of another number. Again, 802, it's going to be 200 remainder 2. So no, 4 is not a factor of 802. So sometimes we're going to get into some questions where we maybe can't do the division in our head or whatever else, and then we might have to rely on some long division skills that we've been practicing. And so just a quick recap to review long division. This is called the divisor. This is called the dividend. The number that's going to go up top here is called the quotient. And so we can do this division. We start with saying how many times does 7 go into 3? Well, it doesn't go into 3. And so you can, if you want, write a 0 to indicate that 7 does not go into 3. But then we start saying, well, okay, how many times does 7 go into 36? And that answer is 5 times. And then it's 7 times 5, which is 35. Then we have to subtract, which is the remainder of 1. And then what we have to do is bring down the 4. And then one of our last steps is how many times does 7 go into 14? That goes 2 times. And then 7 times 2 is 14. And then we subtract, which just gives us a remainder of 0. So then the question at the bottom is 7 a factor of 364? Yes is the answer. How can we tell? Because there's a remainder of 0. When there's a remainder of 0, then this number, in this case the 7, is a factor. And so again, we're going to do some checking here. If 3 is a factor of the number, so we have 3 going into 85. We will talk about some easy tricks to figure out if 3 is going to be a factor of a specific number. In this case, no, it's not going to be a factor of 85. 3 goes into 8 2 times. 6, do the subtraction. So that's 2 left over. And we bring the 5 down. And then 3 only goes into 25 8 times. So that's 20. Well, I might run out of room. That's going to leave us a remainder of 1. So because there is a remainder here, that is not going to work. 3 will be a factor of 72. Because I know the trick to figure out if a number is a factor of 70, or if it's a factor of a number, all you have to do is add the digits in this case, the dividend. So if 7 plus 2 is 9, 3 will go into 9, and so that means that 3 will be a factor of 72 as well. Anyway, 3 goes into 7 2 times, that's 6, leaves 1 left over, carry down the 2, and then 3 goes into 2, or sorry, into 12 4 times. So 3 goes into 72 24 times with 0 remainder. So it means it's a factor. And so the next thing that we can do is starting to consider whether it's easier to skip count or to use long division. So if we're trying to figure out if 3 is a factor of 145, you can start skip counting. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36, 39, 42, 45, etc., etc. The downside to that is that 145 is kind of a big number, and if you're skip counting by 3s, it could A, take you an awful long time, or B, you could lose your place and have to start over, or whatever else. So in this case, it's going to be better to check with long division if 3 is a factor of 145, or you could use the trick where you just add the numbers in 145 together. So 1 plus 4 is 5, plus 5 is 10. 10 is not a multiple of 3, and so 3 will not fit evenly into 145, so it's not a factor. Okay? So what about checking whether 3 is a factor of 14? Well, 14 is a nice small number, and so it's easy to start skip counting by 3, just to say, well, 3, 6, 9, 12, 15. Nope, 3 is not going to be a factor of 14 because I've skip counted right past it. Okay, so it's not a factor of that number either. What if I want to know whether 3,000 is a factor of 14,000? Well, you can skip count there. That's pretty simple. 3,000, 6,000, 9,000, 12,000, 15,000. And so, no, it's not. You're going to skip count right past it. So all to say, when you're choosing between skip counting and long division, you have to look at the number that you're going to be skip counting to and see if it's worth it. If it's too big, you might want to use long division. We've practiced that a lot, and so we should know how to do that. So then some questions about whether or not 6 is a factor. It is not a factor of 32. 32 divided by 6 is 5 remainder 2, so there's a remainder in there. 24 divided by 6 is 4, so yes. 78 divided by 6 is 13 with no remainder, so yes, it's a factor there. And then 6 into 86 goes 14 times with a remainder of 2, and so no, 86 or 6 is not a factor of 86. So no, yes, yes, and no. And then 1926, that is a question that you can probably use long division for, because that will be 321. So yes, it will. So the next thing that we're going to do is stopping when you already find or like a factor appears in a pair, right? So here we have factors of 28. So we have 1 and 28, 2 and 14, 4 and 7. And then nothing for 5, nothing for 6. Notice that the ones that are not factors have x's beside them. I don't have to go beyond 4 really, because 7 already appears in my list. And so I'm just going to stop and not create more work for myself. I don't have to put a 4 here and you know, a 14 here and a 1 here. That's kind of extra work I don't really need to do. And then so just a bit of extra practice here. Factors of 20. Well, I got you know, 1 and 20, and then here is, you know, 2 and 10, 3 doesn't go, 4 and 5. Now notice I don't have to go any further because 5 is the next number, right? So all my factors of 20, 1, 2, 4, 5, 10, and 20. If I do the same thing for 24, right? So I have 1 and 24. I would have 2 and 12. I have 3 and 8. I have 4 and 6. Right? I don't have to go. I don't have to go anywhere past that because 5 is no. I've already got 6 on my list. So my factors are right here. Of all my factors of 24, I have 1, 2, 3, 4, 6, 8, 12, and 24. And that's, like, I'm done. That's it. I don't create more work for myself. That does not make sense. Okay? And so, again, you can save time again by writing only numbers that are factors, even if you do some repeating, right? So factors here of 15, 1, 3, 5, and 15, those are all the factors. Factors of 12, 1, 2, 3, 4, 6, and 12. And then factors here are 14, 1, 2, 7, and 14. Again, don't write out all the numbers if you don't have to. Just saves time. One of the great things I like to talk about with my classes in terms of finding factors is creating something called the factor rainbow, which is kind of a neat idea. And so if we have something like, let's say we have 15, I know that my first pair is 1 and 15. I know my second pair is 3 and 5. Now those are all my factors of 15. But what I can do is actually connect the matching pairs. And so it's like creating a little rainbow. It's a way to not really miss factors. And even if you have an odd number of factors, which happens with numbers like 4 and 9 and 16 and 25, you do a little loop around itself. Anyway, so we have all the factor pairs of 16. No, I need this one. There we go. And so I would say, well, that's, you know, 1 and 16. That's 2 and 8. And it's 4 and 4. I kind of made it too small. But I don't have to go any further because I've already got a repeat there. So these are all my factors of 16. 1, 2, 4, 8, and 16. In terms of 21, I have 1 and 21. I have 3 and 7. 4, no. 5, no. 6, no. And then once I've gotten to that point, and these are all my factors, it's 1, 3, 7, and 21. That's all I have. Again, this is one of those ones where you write out first and second factors. The patterns is it starts repeating after a certain point, right? And again, as these numbers get bigger, the second factors would be getting smaller. Okay, now as soon as we find a number that is already part of a factor pair, we can just stop. That'll do. Okay, so remember, you might need to use long division to look for factors, and when your remainder is 0, the number you're doing the dividing with is a factor. You might be able to skip count. Don't create too much work for yourself. Okay, you can do this one on your own. You can find all the factor pairs of that. You know, so for 42, it would be, I'm going to make the text a bit smaller. Right, it'd be 1 and 42, 2 and 21, 3 and, I'm trying to do that in my head, 3 and 16, right? Not 4, not 5, and then 6 and 7. And then that would be it. Those are all my factor pairs. I don't have to create more work for myself. I'm done. So 1, 2, 3, 6, 7, 16, 21, and 42. So I know I didn't pause in this video as I do sometimes, but I'm almost out of time. So this is the practice. It's page 127, 128, and work on those ones.